Our solar system is full of mysterious objects that come from, well, everywhere. In October 2017, researchers in Hawaii spotted a mysterious thing that they dubbed Oumuamua. This means a visitor from a faraway land in Hawaiian, or that's a really big cow. It followed an escape orbit. It literally escaped from its planet's gravitational pull, like throwing a ball into space, never to return. This meant that this weird thing arrived from somewhere outside of our solar system. There were tons of theories about what it was, from a simple asteroid to an extraterrestrial spacecraft. Scientists even thought it was a chunk of nitrogen ice from a Pluto-like planet. Its strange shape only added to the mystery. The big changes in the light curves showed that this thing could be either elongated like a tube or more flat like a pancake. This thing was unlike anything we've seen before. Oumuamua didn't behave exactly like a comet or an asteroid. Comets are icy and form bright tails when they pass near the sun, while asteroids are basically just rocks and don't form tails. Oumuamua has no tail and doesn't release gas, like me. But it's not your average rock either. Its surface is very shiny, almost like polished metal. When it passed by the sun, it sped up, like it had a rocket on it. And it wasn't the sun's gravity that gave Oumuamua the sudden boost. Scientists aren't sure what caused it. So what in the world was that thing? After years of study, scientists now think that Oumuamua is probably a comet with frozen hydrogen on its surface. This hydrogen reacted with sunlight, speeding up the comet and changing its path. Oumuamua likely got all that hydrogen from being exposed to tons of cosmic rays for a long time. It got some nice red tint from them as well. Oumuamua was a visitor from a young, chaotic solar system where collisions and migrations happen all the time. Such systems often toss many small objects around. It might have been pushed out by a planet like Jupiter, whose gravity is so insanely strong that it can fling huge things into outer space. The same thing often happens with comets here. Oumuamua already left our solar system, although similar objects visit us sometimes, about once per year. To learn more about these mysterious guests, astronomers plan to send a probe to chase Oumuamua. We'll use Earth's and Jupiter's orbits to slingshot it fast enough to catch up with the comet. But some of the unexpected visitors stayed a bit longer. In October 2019, NASA's Hubble Space Telescope took a picture of a bluish comet trailing dust and gas. It was already in the solar system at the time, around 260 million miles away from Earth, somewhere between Mars and Jupiter. We saw the glowing dust surrounding it, but we couldn't yet see its nucleus since it's way too small. Well, small is relative here. The thing is about 3,200 feet across, which is like the length of 9 football fields. In March 2020, Hubble images showed that a small fragment of the comet broke away from the nucleus. That means that the comet is very active, unlike Oumuamua. As we observed it further, we found that the nucleus is a loose mix of ice and dust particles. Its surface is also very similar to others, with rough areas and smooth blankets of icy, dusty debris. The comet was discovered by an amateur astronomer, Gennady Borisov, so it got the name Comet 2I Borisov. Congratulations! Scientists quickly confirmed it came to us from outside our solar system. And this thing sure was an enthusiastic tourist. It traveled at a breakneck speed of about 110,000 miles per hour. That's fast enough to circle the Earth 4 times in just 1 hour. This visit was fascinating for several reasons. Most comets in our solar system come from the Kuiper Belt or the Oort cloud. The Kuiper Belt is a region of space beyond the orbit of Neptune. It's like a big, distant ring around the Sun, filled with many small, icy objects. All of them are ancient leftover pieces from the time when our solar system was still very young. The Oort cloud is much farther. It's like a giant bubble around the solar system, also filled with super old icy objects. Most long-period comets come from there. But where did the comet 2I Borisov come from? We still don't know for sure. Scientists say that it likely formed in another star system, which could be either younger or older than our solar system. Would be weird if there was a third option, NASA. Anyway, it might have been kicked out from its home system, just like Oumuamua. Although Comet 2I Borisov is too small to hold on to its own atmosphere, it developed a coma when it approached the Sun. Now, coma is a funny name for that beautiful glowing cloud of gas and dust that surrounds the comet's nucleus. It forms when the Sun's heat causes the comet's ice to vaporize, releasing dust and gas into space. This one was friendlier than Oumuamua and gave us some more time to study it. As a result, we learned more about its cool, unique traits. For example, it had never interacted with another star. But, unfortunately, Borisov had to leave too. Now it's on a path that will take it back into interstellar space. However, there are many more visitors to come, and you might have heard of this one. The Great Comet of 1996. That's what we call the comet Hyakutake. It was also named after the astronomer who discovered it, Yuji Hyakutake. In a beautiful coincidence, it was discovered on New Year's Eve. On March 25, 1996, this thing passed by incredibly close to Earth, only about 0.1 astronomical units away, a bit farther than the Moon. It passed over the North Pole. This made it one of the closest comet encounters in 200 years. It was visible worldwide, and it looked very bright and beautiful in the sky, stretching out widely. And it didn't stay for one night only. It got more and more visible during March, becoming one of the brightest objects in the night sky by the end of the month. The comet only fully faded by the end of May. It's a long-period comet, which means it takes hundreds of years to orbit the Sun. The last time it visited was about 17,000 years ago, and now its orbital period increased to 70,000 years. But don't be upset, there are other comets that will brighten our days and nights. Besides, some space objects prefer to stay around for longer. Now, there's this asteroid with a multisyllabic name that, to pronounce, is above my pay grade. This name in Hawaiian means the mischievous one of Jupiter. Luckily, scientists had mercy on us and dubbed it BZ. Hey, speaking for all the other narrators, thank you. It's a small asteroid, only about 1.8 miles in diameter. You can guess from the name that it shares an orbit with Jupiter. But there's a cool catch. The asteroid moves in the opposite direction, which is known as a retrograde orbit. The unusual asteroid was discovered on November 2014. It orbits the Sun for about 11 years and 8 months, sometimes passing inside and outside of Jupiter's orbit. It's been this way for at least 1 million years, and it will remain so for about 1 million more. But why does it move so unusually? BZ might actually be an interstellar immigrant. Perhaps it passed by our solar system about 4.5 billion years ago, around the time when the Sun was just forming. Then it got captured by gravity, but saved its opposite orbit. Or maybe it came from the Oort cloud. Then it could get its weird orbit from the mysterious planet 9, a hypothetical planet that's believed to exist in our solar system far beyond Jupiter. In any case, this asteroid gives us more insight into the history of the solar system and how organic materials can travel to us from outer space. Now, at any given time, there are thousands of objects in our solar system that come from outer space. They stay here for different lengths of time, but sometimes we get lucky, and they end up teaching us a lot about interstellar space.
Imagine you could travel through the universe by hitching a ride on space dust, meteoroids, comets, or even rogue planets. Wouldn't it be incredibly cool? This idea is known as panspermia. It has captivated minds for centuries, but despite its appeal, it hasn't gained much popularity among mainstream scientists. Mainly, it could be because it doesn't explain how life originated and isn't easily testable. At the same time, certain events have reignited interest in the theory, even among skeptics. And one of such events was the appearance of the mysterious Oumuamua in our solar system in 2017. Oumuamua was a mysterious object that zipped through the solar system at an astounding speed. It was the first interstellar object spotted passing through our star system and the first detected hyperbolic asteroid, an object with an orbit not bound to the Sun. Observations indicated that Oumuamua was likely to be a highly elongated cigar-like object. Overall, it was a very unusual object. Scientists couldn't quite pin down what it was. Some of them suggested it was a comet, others bet it was an asteroid, and there were those who thought it might be a chunk of frozen hydrogen. In April 2020, astronomers presented a new possible scenario for the object's origin. According to one hypothesis, Oumuamua could be a fragment from a tidally disrupted planet. If true, this would make Oumuamua a rare object of a type much less abundant than most extrasolar dusty snowball comets or asteroids. What made Oumuamua especially interesting to those who support the panspermia theory is that it was a visitor from another star system, so it was possible that it could have carried life across the galaxy. The idea of panspermia advances 3 stages: escape from a planet, transit through interplanetary space, and landing on another planet. Therefore, the Oumuamua hints that panspermia is possible. Recently, a new study titled "The Implications of Oumuamua on Panspermia" has seen the light of day. It was led by David Tsao from Thomas Jefferson High School for Science and Technology, an intern at Johns Hopkins University. The study explored how many objects like Oumuamua might exist and what characteristics they would need to transport life safely across the cosmos. The researchers considered different types of space debris, such as asteroids and comets, and estimated their potential to shield life from harmful radiation, particularly gamma rays from supernovae. If these objects weren't large enough, the intense radiation would sterilize any microorganisms hitching a ride. According to their findings, space debris made of materials like nickel or silicate could provide sufficient protection. But for a passenger to survive, they would need to have a minimum size of about 21 feet. The study also tried to estimate how likely it was that extremophiles, organisms that can survive in extreme environments, could have been delivered to Earth in this way. They calculated that roughly 40,000 objects of at least 33 feet in diameter could have impacted Earth during its first 800 million years. While this number might sound like a lot, the chances that Earth itself was seeded by panspermia are extremely low, less than 0.001%, according to the study. Interestingly, the researchers didn't just consider Earth as a recipient of panspermia, but also as a potential source. If Earth or another habitable planet ejected life-bearing material into space, that material could, in theory, seed other planets across the galaxy. The study suggests that under optimistic conditions, up to 100,000 Earth-like planets in the Milky Way could host life as a result of panspermia. However, many factors remain uncertain. For instance, the number of rogue or free-floating planets in the galaxy could significantly affect the panspermia hypothesis. Hopefully, when we discover more about these planets and the overall density of interstellar material, we will understand more about panspermia. The scientists have also underlined that the conditions in the galaxy were different in the past. For example, during an event known as the Late Heavy Bombardment, the rate of impacts on Earth and other bodies in the solar system was 100 to 500 times higher than it is today. If similar events occurred in other star systems, the potential for panspermia would be much greater. Despite its allure, the panspermia theory remains a fringe idea in scientific circles, all because of the many unknowns and its speculative nature. But as we gather more data from projects like the upcoming Rubin Observatory's Large Synoptic Survey Telescope, which is expected to detect many more interstellar objects and rogue planets, astronomers will likely revisit and reassess this idea.
A shocking theory claims that mysterious comet Oumuamua might be a von Neumann probe, an alien spacecraft with broken engines tumbling through our solar system. It sounds extremely unsettling, but first things first, what is a von Neumann probe? Mathematician John von Neumann suggested the concept of self-replicating spacecraft that could in some ways mimic the features of living organisms or viruses. People started to refer to such hypothetical spacecraft as von Neumann probes. Von Neumann was sure that using self-replicating spacecraft would be the most effective way to perform large-scale mining operations, like mining asteroid belts or moons. The creators of such probes could take advantage of their exponential growth. Hypothetically, a self-replicating spaceship could be sent to a neighboring planetary system and look for raw materials there. Such materials could be extracted from moons, gas giant planets, asteroids, and the likes. Using these materials, the probe could make replicas of itself. The replicas could then be sent to other planetary systems, and the original probe could pursue its main purpose within its parent star system. This pattern sure does repeat the reproduction patterns of bacteria. That's why some experts think that von Neumann machines could be considered a form of life. There's also a theory that a self-replicating spacecraft could spread throughout a galaxy the size of the Milky Way in just 500,000 years, even if it used conventional theoretical methods of interstellar travel. In other words, it wouldn't even need to employ exotic faster-than-light propulsion. In 1981, mathematical physicist and cosmologist Frank Tipler argued that extraterrestrial intelligence couldn't exist because people had never observed von Neumann probes. Even if we take a moderate rate of replication, such probes should already be common throughout space. So, it's really weird that we haven't come across any of those yet. It might only mean that extraterrestrial intelligence doesn't exist. A response to Tipler's arguments came from astronomers Carl Sagan and William Newman. They pointed out that Tipler might have underestimated the rate of replication, and von Neumann probes should have already started consuming most of the mass in our galaxy. Therefore, any intelligent race would avoid designing von Neumann probes in the first place and try to destroy any probes as soon as they found them. Another objection to the prevalence of von Neumann probes is that civilizations that could potentially design such devices have an extremely high probability of self-destruction before producing such a machine. In any case, the assumed capacity of von Neumann probes is unlikely in reality. But then, how about Oumuamua? These days, scientists are using high-tech scanners to examine a huge, cigar-shaped comet, which might or might not be an alien probe. One idea is that it's an extraterrestrial civilization spacecraft, with broken engines wandering through our solar system. If that's the case, the object could easily be a von Neumann probe. Dr. Jason Wright from Penn State University thinks that a broken alien spaceship could move in exactly the same way as Oumuamua. Rather than moving through space like other space rocks, the 1,318-foot-long, 118-foot-wide space traveler is tumbling through the solar system. At the moment, it's traveling at a speed of around 200,000 miles per hour. In his blog, Dr. Wright says that if such derelict craft were not traveling fast enough to escape the galaxy, they could thermalize with the stars and end up drifting around like an interstellar asteroid or comet. They wouldn't have attitude control anymore and would eventually start tumbling. And it could distinguish them from regular interstellar asteroids. Plus, even though their propulsion was broken, their radio transmitters could work just fine. In any case, so far, it's just a theory, and further research is needed. What do you think? Is Oumuamua just a space rock or an alien space probe?
In 2017, a strange object was spotted in our solar system. It had the shape of a long tube, similar to a pancake. No known asteroid or comet we've seen looks like that. Its exterior was also peculiar. It was at least 10 times more reflective than the average stuff that flies through space, with some saying it had a surface similar to polished metal. When it went past the sun and left our reach, it accelerated faster than what our gravity could account for. At first glance, it was like this thing had a rocket strapped to its back. This unusual visitor even got a special name, Oumuamua. It comes from Hawaiian and translates to scout or visitor from a faraway land. And because of its characteristics, scientists soon began to wonder if this was at last a visit from otherworldly creatures. Before they went full-on with the science fiction suppositions, astronomers gathered the information they were sure about, starting with the fact that Oumuamua must have come from another solar system. There must have been some unfortunate event in its home system that led to its ejection. What they didn't know was that this was a comet or asteroid. They're both celestial objects orbiting a sun, but they have distinct compositions and behaviors. Comets are composed primarily of ice, dust, and rocky material, often referred to as dirty snowballs. When a comet approaches the Sun, the heat causes the ice to vaporize, releasing gas and dust particles into space. This creates a bright glowing tail that can extend for millions of miles. Comets generally have elliptical orbits, often taking them from the distant reaches of our solar system closer to the Sun. Asteroids, however, are mostly made of rock and metal. In our neighborhood, they are remnants of the early formation of the solar system and are typically found in the asteroid belt between Mars and Jupiter. Unlike comets, asteroids do not develop tails when they approach the Sun, as they have no ice. Their orbits generally follow more circular paths compared to comets. By all accounts, Oumuamua should be a comet, because it seems to come from a different location in the universe. Yet, it doesn't exhibit the typical signs of cometary activity. Oumuamua lacks a tail and does not spew out gas as it passes by, not like me. Even though it behaves like a comet, it looks more like an asteroid. Now, another big question is how scientists even managed to spot Oumuamua in the first place. Considering the vastness of space and time in the galaxy, it's remarkable. Stars have lifetimes spanning millions or billions of years, and the formation of a solar system takes hundreds of millions of years. Even the fastest objects take tens of thousands of years to travel from one star to another. In contrast, humans have only been observing the skies with telescopes for around 400 years, a tiny fraction of cosmic time. And it's only in recent decades, even years, that we've had the technology to detect and track fast-moving, dim objects. Either rocks like these are abundant, or we've been incredibly lucky with our detections, or it's simply wanted to be seen. Now, another question that was asked was where such objects could come from. It's highly unlikely that Oumuamua came from a mature, stable solar system. That's because such systems don't eject enough material to fill up the galaxy. Occasionally, a random rock might get flung out, but it can rarely travel so far. Young systems, however, act differently. In these chaotic environments, collisions, mergers, and migrations are happening everywhere. Plenty of tiny rocks roam around, perfect candidates for ejection. The solar system that kicked Oumuamua out must have had a planet similar to Jupiter. Its massive size and gravity could influence other objects in the system, causing potential ejections. But not all solar systems develop Jupiter-sized planets. Often massive planets end up close to their stars, becoming hotter versions of Jupiter. These planets, snugly orbiting a sun, are less likely to eject debris. Now, Neptune-like planets may play a role too. While not as massive as Jupiter, they tend to call the outer regions of solar systems their home. Our solar system has the Kuiper Belt, a reservoir of comets in its outer reaches. During a solar system's early stages, interactions between Neptune-like planets and debris are common. Finding Neptune-like planets in other systems has been challenging, though. Our methods for detecting exoplanets work better for massive objects close to their stars, making it difficult to spot Neptune counterparts farther out. Oumuamua was also linked to a peculiar theory about how life came to be in the universe – panspermia. Now that's a hypothesis that suggests that life exists throughout the universe and can be distributed between planets by various means, such as asteroids, comets, or even spacecraft. It says that life must have originated in one location in the universe and then spread to other celestial bodies. Fans of the panspermia theory have suggested that such interstellar objects could potentially carry tiny microbes, those building blocks of life between star systems. If such objects were to impact a planet or a moon, they could transfer these materials and seed the celestial body with life. For now, there is no evidence to support the theory that this comet in particular has transported life between star systems. After years of research, the overall consensus became that Oumuamua was indeed a comet. The reason why it moves so strangely is because it might have frozen hydrogen on its surface that reacts when touched by sunlight. The closer it got to our sun, the faster it became, releasing that hydrogen and also changing its path to our solar system. Its color also supports this theory. It's red, which might mean it's been hit by cosmic rays for a long time. The longer it was touched by those rays, the more hydrogen it gathered in the process. But since they can't be completely sure, astronomers have a plan to follow this visitor. One idea is to send a mission to check it out. It's already far away from us, but it may not be too late just yet. We may be able to send a probe fast enough to catch up with the comet. The plan was named Project Lyra and aims to use the Earth's orbit and that of Jupiter to bounce out a probe far enough to reach Oumuamua. If it works, it will be the fastest space device we've sent out in the universe. One potential trajectory of the space probe involves the gravitational pull of our planet and that of Jupiter as a lasso effect, but not Ted Lasso. The probe will leave our planet and re-enter Earth's orbit before sending it to meet with Jupiter's pull. It will be sent back near our planet a second time, where it will be ejected with enough force to reach the comet. Project Lyra also aims to follow a second faraway visitor named Borisov. This one was discovered by an amateur astronomer and now bears his name. What's interesting about it is that it's, well, spotless. Similar to our experience with Oumuamua, we haven't seen anything like Borisov before either. Studies of the light coming from its cloud of dust and gas show it's very clean compared to other space objects. After it was first noticed in August 2019, astronomers studied its path through our solar system and concluded it came from another star too. But Borisov gave us more time to study it because we spotted it earlier in its journey through our neighborhood. Researchers used advanced telescopes to look at the dust coming off Borisov. They found it's throwing off over 400 pounds of dust every second. They also found Borisov has more carbon monoxide than comets from our solar system usually do. But the amount isn't the same everywhere on the comet. This tells us the space object probably started forming near its home star before moving away, maybe because of larger planets in its system. The light from Borisov is way more polarized than light from other comets we've seen, and its cloud is super smooth. This tells us Borisov has never interacted with another star. You're one of over 8 billion people alive on Earth. Let's zoom out. Our planet is just one of 8 planets in our solar system. In the galaxy, our neighborhood is just one of almost 4,000. And from what we know so far, there are billions of galaxies in the entire universe. That itself may also be growing. It's highly unlikely that we're the only living creatures in the universe. Surely, there must be some other habitable planet. Here's where the Fermi paradox comes in. The idea got its name from a man named Enrico Fermi. Back in the 50s, he pointed out that if other life forms were out there and had the tech to travel through space, they should have visited us by now. These days, we have better telescopes that allow scientists to discover over 5,000 planets outside our solar system. Yet, still no sign of life. Throughout the years, there have been many suggested solutions to the Fermi paradox. These outer world beings may be just too far away for a friendly chat. We've seen it in movies, spaceships traveling between stars as easily as cars on a highway. But in reality, making a way through space is a slow and cumbersome process. Even our fastest rocket would take thousands of years to reach a nearby star. When you add in the vastness of the cosmos, it's like trying to find a living needle in the biggest cosmic haystack available. Now, we could just as easily be the very first civilization to emerge in the universe. It's a lonely thought, and it also puts a lot of pressure on us. If we're the only ones, we need to preserve life on our planet, not just for our sake, but also because if we fade away, all life fades away with us. The universe has been around for billions of years, but intelligent life like ours has only existed for a tiny fraction of that time. Maybe we're just early bloomers, waiting for someone else to catch up. To support this theory, a study was done in 2015 using the Hubble Space Telescope. And this is what it showed. Out of all the worlds that could sustain life, only 8% are as old as the Earth. The rest of them are too young and still haven't reached that point in their evolution for life to thrive. There could also be the possibility that our galactic relatives are watching us from afar. A scientist from another planet may be studying us as primitive life forms right now. He may not want to disturb us just yet, the same way we look at ants in an ant farm during science class. On that same note, maybe they're just not ready to interact with us because they've calculated a precise, perfect timing for our meetup. So they're lying dormant in a hibernation status. And they might be right to do so. Why rush into things when we've got all of eternity ahead? There's also the idea that our planet and us humans just aren't cool enough for others to play with, and won't be until we're evolved enough to be welcomed into the Galactic High School's senior class. Or perhaps life is more fragile than we believe. A 2016 study suggested that it's in the early years of a planet where life makes its way. That's when the planet is cool enough for water to form. But those conditions may not last long thanks to the greenhouse effect. So even if life has existed in the universe every now and then, it never evolved to a stage where it could have contacted us. And what if life's ultimate test comes much later? Several thinkers believe that civilizations tend to destroy themselves at some point in their technological evolution. And this may be a potential future for us, too. We're just not there yet. Maybe we'll come to build technology so smart and so powerful that it will overwhelm us, leading to our demise. Well, if it can happen to us, who's to say it didn't happen to other species in the past on other planets? Amidst all these theories, there's one possibility that's both sobering and profound. We may truly be alone in the universe, forever. Perhaps the conditions for life are so rare that Earth is the only oasis in a vast desert of emptiness. The creepiest answer to the Fermi paradox has a name, though, and it's called the dark forest theory. It first appeared in the 1980s. According to it, the universe is a huge version of a haunted forest, and other types of creatures are out there playing a game of hide-and-seek. It's the expanded version of the survival of the fittest. History on Earth shows that less technologically advanced groups usually end up worse off when meeting more advanced ones. The huge differences in technology often lead to a situation where attacking first seems like the best option. If there's even a small chance that cosmic neighbors might harm us, destroying them first could be our only hope. So if the galaxy is full of advanced life, it's smart for us to stay quiet and avoid contact. Other civilizations would probably reach the same conclusion. Even peaceful ones might feel forced to attack to survive. That's why some scientists criticize the idea of sending messages out there and think searching for them might be pointless. But this idea isn't new. A story from the 40s called First Contact describes humans meeting other types of civilizations for the first time. The two groups became friends, but can't risk letting each other find their home planets. They'd rather destroy each other than risk their safety. Another story, The Forge of God, talks about the danger of our signals reaching hostile species. It compares Earth's broadcasts to a baby's cries attracting wolves. It suggests that we might be in danger because of our naivete. The dark force theory was also explored in a radio play called Calls from Far Away. It shows how discovering otherworldly life on Pluto changes people's views. Some claim the news is fake. Others try to understand the reality that we're not alone. But it also suggests that maybe we should focus on our own problems instead of reaching for the stars. If that doesn't sound scary, this will. We've been sending signals of our existence into the cosmos for decades now. By now, any potential civilization within 100 light-years of us might be getting our signals. And if they're advanced enough, they'll know exactly where to find us. If there's any reason why we need to hide from them, it's already too late. Galactic cousins aside, we do need to continue our research for habitable planets for a more pressing reason. Our cozy Earth won't be here forever. When our star fades, all life within the solar system will fade with it. Current estimations claim we've got about 1.3 billion years left before our planet becomes uninhabitable. It will become too hot for water to exist, and without water there is no life, at least not as we know it. So, it begs the following questions. What if there are other types of creatures out there that don't need water to exist? Our type of life needs water because it acts as a solvent. It's an environment where various chemicals can interact with each other to generate something that lives. Some new piece of research suggests that there may be a substitute for water out there in the universe – carbon dioxide. At certain temperatures and under a certain amount of pressure, it acts the same way, allowing chemicals to mingle. If that's true, then our list of known habitable planets would increase dramatically. Sure, we humans will probably never be able to survive on their surface, but other creatures may have evolved to do so. One planet that may feature these weird life conditions is closer than we think – Venus. Its atmosphere is made out of 97% carbon dioxide. It's also very hot and has enough pressure to sustain this theoretical model. If alien life exists, it may be way stranger than we can imagine. For some inexplicable reason, we've long assumed that aliens might be like us humans. But in reality, they're more likely to be some form of unfathomable AI. With dozens of billions of years of evolution, intelligence can develop in entirely new, unexpected directions. Humans might be near the end of Darwinian evolution. We no longer need to remain the fittest to survive. But the technological evolution of AI minds is just starting. Who knows, maybe in another century or two, we'll be overtaken by inorganic intelligence. So, the question is, are aliens more likely to be flesh and blood, like us, or are they something more artificial? Even though many believe that people are at the peak of intelligence, it's possible that our species may just represent a stage on the way toward more artificial and advanced minds. And it can actually explain why space seems to be empty of similar forms of life. Perhaps an evolutionary transition to non-organic intelligence is inevitable all over the universe. Then aliens could be electronic descendants of once organic creatures that existed long, long ago. Such an idea gives us some exciting possibilities. If AI aliens were out there, they would act and think totally differently from us. Plus, they might not want to be detected. Non-organic intelligence may not need an atmosphere, so they might have already left their home planet. If they didn't need any special conditions, they would be able to make intergalactic voyages without having to fear for their lives. They could prefer to live in zero gravity because, in such conditions, you can build very large and very lightweight structures. For example, if you wanted to construct a giant gossamer-thin structure to harvest energy, it would be easier to do so in space than on a planet. They might not even need to live in orbit around a star. They could have innovative ways of getting energy we can't imagine yet. If their brains were silicon-based, they could realize that they needed less energy to process information at lower temperatures. So, they would move away from planetary systems to colder regions of the cosmos. They could even have periods of hibernation for billions of years. What if they had such a period waiting until the cosmic microwave background, the leftover radiation after the Big Bang, cooled down enough for them to function properly? We can't assume that these aliens would be a civilization either. On Earth, this term means a society of individuals. But aliens might be a single integrated intelligence, or they might be zombies, super intelligent but lacking self-awareness and inner life. In this case, they would be alive but unable to perceive themselves or the world around them. Alternatively, their advanced intelligence might allow them to understand aspects of reality we can't figure out yet. There are likely to be things in the universe that neither our mind nor our senses can grasp. But electronic brains might have a very different perception. Interestingly, these days, humans themselves are starting to use AI to detect alien life out there. After all, there are between 10 and 50 billion potentially habitable worlds in our galaxy alone, and looking for intelligent life is a hard task without some assistance. That's when the US-based research organization, SETI, Search for Extraterrestrial Intelligence, comes into play. This institute is looking for science and technology beyond the solar system. It could be evidence of intelligence out there. But it's a needle in a haystack kind of situation. Luckily, new instruments are helping the search. Artificial intelligence can both handle massive datasets and spot anomalies, which is transforming the hunt for alien intelligence. SETI, together with other research organizations, built an AI-powered software system called the Very Large Array. It consists of 28 large dish antennas spread across a desert plain. When it starts working, the AI will be able to process 2 terabytes of data every second. For comparison, modern laptops typically have around 1 terabyte of total storage. So, hopefully, these new tools will provide us with new, groundbreaking discoveries. According to the theory of panspermia, life could have been brought to Earth by a meteorite, comet, or asteroid from a different region of space. At the moment, this idea remains purely theoretical. But let's figure out if it could actually turn out to be true. Traditionally, exobiologists, those who are focused on searching for life outside Earth, have been trying to explore the possibility of life on Mars or in the subsurface oceans of Saturn's and Jupiter's icy moons. But simple life could be much more widespread. It could be drifting through interplanetary space right now, in the form of dormant bacteria and spores. Several scientists have noted that the ultra-harsh environment of space is likely to severely damage the DNA and RNA of such spores and microorganisms. Others believe that since enough microbes could be traveling in a dust cloud, some of them could survive in their original form. There are several types of panspermia. For example, lithopanspermia proposes that some kind of microbic life could exist in debris blasted into the cosmos after planetary collisions with comets and asteroids. Radiopanspermia claims that organisms might be able to travel through space with the help of radiation coming from stars. But in this case, it's unclear how the effect of dangerous ultraviolet and X-ray radiation, combined with the vacuum of space, doesn't totally destroy microorganisms. There's also pseudopanspermia. According to it, organic building blocks of life appear in interstellar clouds of dust. They get transported to the surfaces of planets, and life starts developing there. It sounds really fascinating, but is there any evidence for the panspermia theory? Well, there have been a few orbital experiments. For example, from 2008 to 2016, the samples gathered by EXPOSE, special equipment mounted outside the International Space Station and dedicated to astrobiology, were exposed to the conditions of space. After that, they were returned to Earth from the ISS. It turned out that some of them had survived those severe conditions. There was even a case when 100% of bacterial spores placed in Mars-like conditions were still capable of life. Also, some seeds survived and were later grown as plants on Earth. There have also been exostack experiments on the U.S. Long-Duration Exposure Facility satellite and biopan experiments on Russian photon capsules. They have shown that with minimal protection, spores, lichens, and even minuscule animals, such as tardigrades, might be able to survive in space for as long as several years. A piece of Surveyor 3 lunar lander was brought back to Earth in 1969 by the Apollo 12 mission. Shockingly, it contained an Earth bacterium that had survived unprotected for more than 2 years on the airless surface. At the same time, this bacterium could have come from laboratory contamination on arrival back on Earth. The Indian Space Research Organization carried out a search for space microorganisms too. It was done at stratospheric altitudes via balloon flights. The results showed that living interplanetary cells existed in air samples taken from heights of above 25 miles. Normally, air from lower levels of the atmosphere can't be transported there, so this discovery seemed to prove the theory of panspermia. But in 2010, NASA atmospheric sampling before and after hurricanes proved that under certain circumstances, Earth bacteria could actually be transported very high into the upper levels of the atmosphere. One of the main arguments against panspermia is that if this theory was correct, all life found throughout the solar system would have a common origin and share main biochemical characteristics like genetic code. It doesn't sound plausible. Many specialists believe that only the presence of astronaut explorers on the surfaces of, let's say, Mars, Europa, or Enceladus can properly solve the question of life in the solar system. They can compare any life forms found with Earth-type life, which can turn out to be a real test of panspermia. In any case, until probes finally find direct proof of spaceborne life, the panspermia theory will remain unproven.
What makes space so terrifying is its unpredictability. Even though 99.99% of the cosmos is a vacuum, if you encounter something of substance, the chances are high that it might easily end your life. And still, some things are scarier than others. For example, gamma-ray bursts. When a galaxy explodes, it releases a powerful burst of gamma rays, and those can completely annihilate any asteroid or planet in their path. A gamma-ray burst occurs in our home Milky Way galaxy once every 5 million years or so. Then there are vampire stars. Scientifically, they're known as O-type stars. Those are enormous blue giants attached to way smaller stars, which gradually get consumed by the gravitational pull of their huge neighbors. But vampire stars don't live long, happy lives. Once a space vampire has consumed a smaller star, it explodes into a supernova torn by its own gravity. Black holes are both endlessly intriguing and terrifying. They consume everything that comes too close and bend space-time around them. Can they get any scarier? Definitely, once we look at rogue black holes. One of them was discovered in 2016. This rogue black hole is heavier than the Sun and is moving at a speed of more than 1,240 miles per second. This black hole could have broken away after the collisions of its home galaxy with another one. At the moment, it's around 2 billion light-years away from us. Now, how about a mysterious space anomaly called the Great Attractor? This area lies around 150 to 250 million light-years away from our galaxy. The Great Attractor's gravitational pull is so powerful that it can move entire galaxies toward itself, making them collapse with one another. But the scariest thing? We still don't know what it is, and whether our galaxy will end up in its clutches one day. Meteors might not sound particularly exciting or scary, but they are some of the most realistic threats to our planet. Thousands of meteorites hit Earth every year. Luckily, most of them are too small to cause any serious harm. They either burn in the planet's atmosphere or crash into the ocean. Our own sun can be pretty scary too, especially when it produces powerful bursts of energy, solar flares. They often go hand in hand with coronal mass ejections. Those are giant bubbles of ionized gas that can accelerate to incredible speeds. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with the temperatures reaching several million degrees. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. A powerful solar storm can potentially cause a devastating global blackout on Earth. The next scary space phenomenon is the dark flow. All galaxies are supposed to be moving uniformly away from one another. But there's one large group of clusters that seems to be moving at a speed of 600 miles per second toward a small region of space between the constellations Centaurus and Vela. There seems to be no apparent cause for this, which is why this inexplicable phenomenon got its name. The cosmos also presents many dangers for astronauts. For example, extended space travel can apparently change human DNA. According to scientists, the stress from staying in space for too long might cause astronauts' cells to rewrite their genetic code. The worst thing is that such DNA changes are permanent. According to a new unpublished study, one of the brightest stars you can see in the night sky is likely to explode within our lifetime. The star in question is a red giant called Betelgeuse. It's located in the left shoulder of the constellation of Orion. The star might have no more than 300 years' worth of fuel left in its core. Once it burns through these last reserves, the core will collapse, forming a black hole. As for the star's outer layers, they are likely to be blasted out into space at a mind-boggling 25,000 miles per second. This is what astronomers call a supernova. If Betelgeuse goes supernova, it will be a spectacular sight to watch from Earth. The star is comparatively not far from our planets, just 650 light-years away. So those layers of ejected gas and dust will shine as bright as the full moon. It will also last for several weeks. Interestingly, most astronomers don't believe Betelgeuse is ready to go kaboom yet. Then, what makes the authors of the new paper think otherwise? Well, this star is definitely a red giant that has burned through its primary fuel, hydrogen. At the moment, it's most likely fusing helium remaining in its core into some heavier elements. The point at which a star runs out of its hydrogen is unmissable. When a star is short on hydrogen, it needs to put extra energy into igniting the helium created during the process of hydrogen fusion. These additional efforts make such a star expand dozens of times beyond its original size. It also becomes redder and cooler in the process. Astronomers know that Betelgeuse is very, very large. If you placed it at the center of our solar system, its outer atmosphere would reach so far that it would swallow Jupiter. But it's hard to measure the exact diameter of the star. All because Betelgeuse is not your regular smooth ball of plasma. Instead, it's a lumpy chunk of boiling gas bubbles hiding behind dust clouds. This is the main reason why measuring the size of the star isn't easy. But to determine the star's remaining lifetime, we must know its diameter. And a team of scientists from Japan suggests that Betelgeuse is larger than most astronomers think. The star is known to pulsate. It expands and shrinks, dims and brightens again and again at regular intervals. Researchers link these changes to the periodical expansion of the star's outer region. There are other oddities in the behavior of the star. They appear on a regular basis too. Astronomers see the connection between these quirks and turbulent processes taking place inside the star, which seems ready to go out. The research team behind the new study believes that Betelgeuse's main pulsation mode is represented by the 2,200-day cycle, and the 420-day brightness variation might be the star's secondary quirk. For this scenario to work, Betelgeuse needs to be up to 1/3 wider, and to be as wide as necessary for this model, the star has to be in a later stage of its life, done with burning helium and, instead, running on carbon received from previous fusion of helium atoms. Whether a red giant is burning helium or carbon makes a great difference in terms of how much time it has left. If it's still in its helium-burning phase, the red giant can live for tens of thousands of years. But if it's already in the carbon-burning stage, the end is near and might come within a few thousand years. In the case of Betelgeuse, we can't determine exactly how much carbon the star still has, but carbon exhaustion might happen as soon as in 300 years. After that, fusions of heavier elements might take a few dozens of years. When it's over, the core will collapse and a supernova explosion will occur. Our galaxy is home to 200 billion stars and maybe 100 billion planets. Let's imagine that life exists on a tiny fraction of those places. And let's imagine that those lives could evolve into intelligent beings. Given that, it would seem safe to say that our galaxy would be populated and some species would be actively trying to find us. We have an equation called the Drake equation that can estimate how many intelligent civilizations might arise in our galaxy. The equation suggests that there should be around 20 civilizations just on the outskirts of our galaxy. So why haven't we encountered any of them yet? The work of Frank Drake, a radio astronomer published in 1961, is a set of many variables, such as the average number of planets in a solar system that could potentially harbor life, or the rate at which stars are suitable for intelligent life form. The complexity here is that astronomers have yet to determine the exact values of these variables, meaning that our calculations are still only approximate. But recent discoveries in these areas give us hope that we can refine these estimates. Let's use our hypothetical assumptions and apply them to our galaxy. Let's crunch the numbers, and it comes up to at least 20 civilizations. And yet, somehow, the sky remains strangely silent. How did this happen? Some people think that the appearance of life is a rare event. Others think that the transition from bacteria to highly developed beings is a difficult step. Still, others believe that civilizations may either destroy themselves after a short lifespan, or may never even invent something with which they could communicate. But there is one theory that surpasses all the others in its creepiness: the dark forest theory. According to it, the universe is a vast cosmic version of a haunted forest, and other kinds of beings are out there somewhere playing hide and seek. They are deliberately keeping silent. Why? Well, for starters, every form of life wants to survive. If we start with that assumption, we can ask the question, will other forms of life harm you if they have the chance? So, the safest option is to destroy them before they find the right time to do the same to you. Frankly speaking, this is a cosmic version of survival of the fittest. In this scenario, making contact with others becomes the most dangerous game, as it could lead to your location being tracked down and you being destroyed. The theory was proposed by scientist David Brin as a possible explanation for the lack of radio evidence for the existence of life. But how realistic is this theory? Only one advanced race behaving in this way could answer that question. So far, this theory explains why we are not picking up any advanced radio transmissions despite a century of listening. It is possible that other beings like us are too afraid of being noticed and have deliberately gone silent. It is worth considering that there may have been a point at which everyone decided to keep quiet. Was it an aggressive civilization that deliberately wiped out the noisy aliens? The question is open. For about a century now, we have been those very noisy aliens. Any other civilization within 100 light years of us can receive our signals and know exactly where we are. And if we have reasons to hide from them, as some people such as Stephen Hawking suggest, we may already be in trouble. So, will we ever receive a message from our cosmic partners? Only time will tell. But what we do know for sure is that we cannot just brush this off. We cannot allow panic to spread across the planet when we receive that alien WhatsApp. We need to have a plan, and we need to have it ready by the time we are faced with the real situation. The US authorities have investigated over 100 cases of strange phenomena occurring in the sky. No little green men have ever been found, more likely drones and similar objects. Whether our intergalactic neighbors will send us a message tomorrow or centuries later, we need a plan. After all, this could change everything we know about our universe and our place in it.